बार फिर से स्वागत है into my YouTube channel Study with Mukesh Raj. Here today we will be continuing with the topic that we have started already, that is polynomials, and today we are going to discuss on the topic of zeros of the polynomial. But before that, let me apologize for the fact that I have been out of my YouTube channel since a long time, and for that I am really very sorry. Hope to see you in the coming videos consecutively from now onwards. Thank you friends. Please be onto my channel and please do not forget to like, share and subscribe, and please do comment, and I will definitely give the reply of those comments. So without wasting time, let us continue with the topic zeros of the polynomial. Zeros of the polynomial means that suppose that we are having a polynomial of the form x of the variable x, and p is the denotation of the polynomial, and let's say I am representing a quadratic equation ax square plus bx plus c. So whenever we talk about the zeros of the polynomial, it means that we are interested to find the we need to find the solutions. We need to find the solutions. Now these solutions are meant in the form that the values that whenever we put those values and we get a result. Fine. So, and the solution depends upon the degree of the polynomial. So friends, we have already discussed, and I had made a separate video for this topic where we will be finding out the degree of the polynomial. So I am going to put the link of that particular video into my description box for your reference. So please do go and have a look onto that. Now, since in a quadratic equation we have the degree that is equivalent to 2, so the number of solutions that we will be having, solutions that we will have will be equal to 2, and let's denote these solutions in the form of alpha and in the form of beta. Now what are these? Alpha and beta are the solutions for the variable that is x. So number of solutions for the variable in the polynomial where we are having a quadratic equation, this can be represented in the form of alpha and beta. So let us move on to the topic with the formation of this. Let's say this polynomial have two solutions, which is denoted by the degree. The highest degree of this polynomial is 2, therefore it has a solution that is equivalent to 2 in the form of alpha and beta. Now these solutions or the degree will be represented in the form of the two representations are there: sum of the zeros and the product of the zeros. Sum of the zeros and the product of the zeros. Now the thing is that whenever we are trying to represent, this means that after you obtain a solution to this equation, quadratic equation, these solutions, that is the representation of the values variable that is alpha and beta, could be done in the form of the zeros, sum of the zeros and the product of the zeros. So for that we have a representation like this. We can say that the alpha will be added to beta, and this could be represented in the form of like minus b upon c. Now what is this? B is the coefficient of the variable x and c is the constant coefficient or the coefficient of the value for the variable where we are having the exponent of the variable that is equal to 0. Now whenever we talk about the product representation, the product representation could be done in the form of alpha beta, and that value is equivalent to or equal to the representation of, that is minus c upon a. Alpha and beta, that is the product of the zeros, will be represented by the form of the ratio of the constant coefficient of constant of the variable x square and the and the variable coefficient of the c, that is at the end of the equation. Now at last, if we want to represent the same equation, this polynomial, quadratic polynomial, could be represented in the form of alpha and beta, could be rewritten in the form of alpha and beta. Let's see how we can write it. The same equation can be written like this. It will be written like this: x square plus, we have alpha plus beta, it will be multiplied by x, and then we can write here alpha beta. So this is the representation of the quadratic polynomial with respect to the zeros of the polynomial that we have found. Now once again I am going to tell you about the zeros. Is that zeros are nothing but these are the values. When we put these values, while putting these values, the equation becomes, the value of equation becomes 0. So this is about how we can find the zero of the polynomial, particularly in the case of a quadratic equation. Now let us understand this representation of the zeros, that is the sum of the zeros and the product of the zeros, in context with an example. Now taking an example, let's say I am having a polynomial which is denoted by a variable, that is f, and with respect to the variable x. Variable x denotes the variable into which it will be represented. Now x square plus 7x plus 12. So I have taken a very simple example to demonstrate you that how we can find the zeros of the polynomial. At the same time, how is it that we can represent the same equation, the fx, the polynomial fx could be represented with context to the sum and the product of the zeros. See, first of all, we would try to find out this the zeros. Now we need to find out that first of all, the product of the zeros should be equal to 12 and the sum of the zeros should be equal to 7. Now we have to take into consideration the symbols, the sign. It plays a very vital role into it. So while multiplying the zeros we should get 12, and while adding we should get 7. So keeping these two things into mind, we will start prime factorizing the product of the polynomial, that is 12. So these are the factors 2, 2 and 3. So we have to arrange these three values in such a way that on multiplying we should get a positive 12, and while adding this we should get a positive 7. So what combinations can we try? Let us try a combination of these two, 2 multiplied by 2 and then 3 as an independent value. So 4 multiplied by 3 will give you a 12, that is positive, and when 4 it get added with 3 you will get a positive 7. So by taking this combination we are able to find out the product as well as the sum, that is represented in the form of 7 as in the equation. Now moving forward, now what we will do, we will take this is the zeros, these are the two values of x which when put into the equation will give us a net equation value equal to 0. So we can rewrite this equation like this: f of x can be written as x square plus 4x plus 3x plus 12. Hope you would be connecting with this, and then we have to split it. Now since there were 3 terms and now here we are having 4 terms, so we can group these terms into a pair and then we can find out the zeros of this. X taken out as common, then we will be having x plus 4 as here, and then again I am going to take 3 as common, which will give me x and 4 at this end. Now see, x plus 4 is one of the factors. So these are the factors. This is the factor and the another factor is x plus 3. If I want to say that so either x plus 4 is equal to 0 or x plus 3 is equal to 0. So consecutively it implies that for this particular x, if we put the value of x equal to minus 4, then the entire equation will be equal to 0, or if we put x equal to minus 3, then the entire value equation will be equivalent to 0. Now when it comes to the finding out the alpha and beta, so here alpha will be equal to minus 3 and beta will be equal to minus 4. Is that clear? Is it clear, dear kids, my dear friends? Now keeping this in mind, so this is the value for the zeros. Alpha is equal to minus 3 or beta will be equal to minus 4. This is either of the case, either alpha will be equal to 3 minus 3 or even beta can equal to be minus 4. Now let us verify this, whether this value is being verified appropriately with respect to the concept that we have discussed. Representation as sum of zeros. Now how can we identify? We know that sum of the zeros, that is alpha plus beta, will be equal to minus b upon a. Got that? Now let us first of all identify b. What is b? B has got a value equal to 7 from the equation, and from equation we can say that b is equal to 7, and then value for a is equal to 1. Now let us verify it. We know that alpha plus beta, that is 3 plus 4 is equal to 7. This is for left hand side. Now for right hand side, minus b upon a, what is that? Now minus b stands for b minus, and b has a value that is minus 7, and then a stands for 1. So here we will be getting a value that will be equal to minus 7. This is equal to RHS. Here we can say that since we have got LHS equal to RHS, so it satisfies the sum of the zeros. Similarly, let us talk about the product of the zeros. That is the product. Now product of the zero is alpha multiplied by beta. Now we have seen that alpha multiplied by beta will be equal to C upon A. See, LHS. Okay, before that, let us find out the value from the equation. From equation, we have to find out the value for C. C is equal to 12. Then we have A equal to 1. I have not used the sign because both these values are positive in nature. That is why I have not used the value sign, symbol plus. Now LHS can be written like this: alpha multiplied by beta, that will be equal to 12. Sorry, I am extremely sorry. That is minus 4 multiplied by minus 3. This will be equal to minus, not plus 12. Minus multiplied by minus will give you a value that is equal to positive. Now LHS becomes this. Now RHS will be equal to, as per this, that is C upon A. Value of C from the equation we have found, that is equal to 12, and A is 1. So this could be even written as plus 12. Hence we can say that LHS is equal to RHS. So this is the representation of and verification for the product and the sum of the zeros. So this was for the quadratic equation, and we will be looking into the finding of the zeros for the polynomials for cubic and biquadratic equation in the coming session or the coming videos. So that's all for watching, friends. Thank you. It was great sharing my information with you. So please do not forget to like, share and subscribe, and if possible please do comment on my video. Thank you.